Hello, seniors. I hope you had a good winter break. Today, we're gonna continue with our last IB topic, which is calculus. We're gonna continue working with derivatives. Today, we're gonna see a new type of derivative, which is known as the chain rule. Okay, so the objectives for today's class are to first apply the product and quotient rules for differentiation, which is something that you already know. And second, apply the chain rule for composite functions, okay? So there you see kind of an idea of what the chain rule is about, is whenever we have composite function, okay? So we're gonna review composite function, which is a topic that we've seen at the beginning of last year. Okay, so let's start by trying to find the derivative of this function, which is there in red. It says find the derivative for f of x equals 2 minus x to the cube power. To the power of 3, right? How do you think we can find the derivative for this function? We may think about applying the power rule, right? If you remember, for example, if we want to find the derivative of x squared, the derivative is directly 2x, right? If we apply the power rule, right? But what happens in this case? In this case, I cannot apply the power rule because, okay, let's say that f of x is 2 minus x cubed. If I try applying the power rule, what will happen? I will find the derivative and I will say it's 3 times 2 minus x squared, right? But this is not correct because we don't have a single x in here. We have a function instead, which is 2 minus x, right? So I cannot apply the product rule only in order to find the chain rule. There's another thing I need to do. Okay, so without knowing chain rule, the only way I may think about in order to find the derivative is to expand this function and then see what happens, right? In order to expand this function, what I can do is rewrite 2 minus x 3 times, right? Because it's cubed. So times 2 minus x times 2 minus x times 2. Wait a second. Times 2 minus x. There you go. So if I perform this, I need to do the multiplication, right? Give me a second. So if I perform this using the FOIL method, first I would work with the first two parentheses, right? This times this, this times this, this times this, this times this, and so on. Okay, so I will get as my function, this would be 4 minus 2x minus 2x plus x squared. And all of this is being multiplied by 2 minus x, right? So if I keep on working with this, I can see that I have similar terms here. So this would be 4 minus 4x plus x squared, and this is being multiplied by 2 minus x. Now that I have this, I can do FOIL again, right? This time this, this time this, this time this, time this, and this time this, and so on. Okay, so I will have 6 terms in total. So this would be equal to 8 minus 4x minus 8x plus 4x squared. Then we have plus 2x squared minus x cubed. I hope I didn't make any mistake. So now if I add like terms, we're gonna have, this would be, let me see, negative x cubed first of all. Then these two are like terms, so this is plus 6x squared. And then we have minus 12x. And finally, plus 8. Okay, now that I have expanded this expression, now I can find the derivative by applying the the power rule, right? This is something that we already know. So if we find f prime of x, this would be equal to negative 3x squared plus 12x minus 12. And this is the derivative of the initial function we wrote here, okay? Now, we're doing this long process just because we don't know the chain rule. The chain rule will help us shorten this process a lot, okay? So this is what the chain rule is about. Here it says, the power rule alone will not give the correct derivative for f of x equals 2 minus x cubed. This is because the function is not a power of x, but rather a power of another function, v of x, which is equal to 2 minus x. That's what I told you here at the beginning, right? The function f is a composite function. If you remember the symbol for composite, UOV, or FOG or GOV, remember? U of v of x or u of v of x, where u of x is x cubed and v of x is equal to 2 minus x. Here it says the symbol in the composite is used to show a composite function. If ux equals x cubed and vx equals 2 minus x, then f of x is u of v of x, or u of v of x, which is u of 2 minus x, which is 2 minus x cubed. Okay, so I'm going to quickly show you how to apply the chain rule in order to solve this particular derivative, to find the derivative of that function. And then we're going to see more in depth the concept of the chain rule, and we're going to practice with a lot of exercises, okay? So, how do we solve this derivative using chain rule? First of all, I'm going to write the function f of x, which is 2 minus x cubed, okay? 2 minus x cubed. So the first thing I want to do is identify the composite functions. That means identify the two functions that together form function f, right? So this is just by inspection, right? I can say that ux, for example, is equal to x cubed, because I know that it's something which is being to a cube power, right? So u is x cubed, and v of x would be whatever I have inside the parentheses, which is 2 minus x. So you see, let me do that with that different color. If I find u of v, let me do this correctly, u of v of x, remember that means plugging in function v into function u, right? So if I find that, I'm going to be doing 2 minus x cubed, which is exactly our function f, right? So that's just a way of checking this. So if I am able to write a function by using the concept of composite functions, then I can apply the chain rule. The chain rule states that the derivative of a function is equal to, and it's like this, it's the derivative of the outside function, that is of x cubed. Let me do that before actually finding the derivative. I'm gonna write the derivatives of each function. So u prime of x, the derivative of u is 3x squared, right? And the derivative of v is 2 minus x, that would be 0 minus 1, right? So negative 1 is the derivative of v, sorry. So the derivative of function f is the following. It's the derivative of the outside function, which is u, in this case. U is the outside function, and v is the inner function. So the derivative of the outside function, which is this, but we need to keep the original value of x, which is the function v, okay? Don't worry if you're getting confused here. We're going to see this with a lot of exercises. So it's 3 times x squared. So instead of writing x, I'm going to write the original v function, this, times the derivative of the inner function, which in this case is negative 1. And that's it. This is the derivative of function f. So let me rewrite this. F prime of x is equal to, this would be negative 3 times 2 minus x squared. Okay? This is the derivative of function f. And if we expand this just to check if it's the same as this, I'm going to try expanding this, but this is our final answer already. I'm going to do this with a different color just to verify that it's the same thing. Okay? So if I expand this, I'm going to say that this is f prime of x, which is equal to negative 3 If you remember how to expand whenever we have squared, is this value squared, which is 4, minus 2 times this. So it's 2 times negative x, write it in parentheses, times negative x, and then plus the last term squared, plus x squared, right? So if let me take this up here. If I continue expanding this, or simplifying actually this would be equal to f prime of x, which is negative 3 times 4 minus, or plus 4 plus 4x plus 4x plus x squared. And finally, if I multiply the negative 3 I have outside, if I reorganize these terms, it would be negative 3x squared would be the first term, then minus 12x and minus 12 again. This would be our final answer, which should be the same. It's not getting exactly the same, I don't know why. Ah, yes, sorry, this was plus 12x. There you go. So it's negative 3x squared plus 12x minus 12. And that's exactly what we got here. Negative 3x squared plus 12x minus x. Okay? So you see that if you understand the chain rule, this just has 2 steps, right, in order to find the derivative. Okay? Don't worry much about if you haven't got this, or if you didn't understand well what happened here. You'll see that we're going to be doing lots of exercises following this class where you're going to see how to apply the chain rule correctly. Okay, so to avoid making this class too long, I'm going to leave this here. So next class we're going to move on to the definition of the chain rule, and we're going to see lots of exercises in order to practice this concept. Okay, so I hope this was clear, and if not, please let me know, and we're going to try to clear your doubts. See you.